I remember when we hit 100 in Dobbin's class, we got that up with back then when we had the cool t-shirts.
You get to do stuff for Pi Day next week, so relax.
Really?
Really?
We get to like eat pie.
Can I make that chocolate pie that I did?
If you really want to.
I will.
All right, so I do want to get started on this next section. It has to do with secants, tangents, and angle measures. So this section is one of the more challenging ones. So you do want to pay attention. Make sure you're taking good notes today. Okay. I am going to use a highlighter if you want your highlighters out. If you're highlighting with me here. So first off, a secant is a line, okay, that intersects a circle in exactly 2 points. Okay, so it is a line that goes all the way through the circle. So at the right, lines J and K are secants of circle C. Okay, so line J hits circle C at 2 points. It's a line, it extends, it has arrows. Same thing with line K. Hits circle C at 2 points. So those are secants of that circle. So the first thing we're going to look at is the intersection of two secants inside a circle. Okay, so intersections inside the circle. So when two secants intersect inside a circle, the angles formed are related to the arcs they intersect. So in words, we're going to use this theorem here. If two secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. Okay, so if I wanted to find the measure of angle 1 in the circle at the right, okay, measure of angle 1 is here. Its vertical angle is the one across from it. Now, vertical angles are always congruent to each other, okay? So both of those I could consider as angle 1 since they're congruent. So to find that measure, you're going to take the arc that angle 1 intercepts, which in this case would be AB. You're going to add it to the arc that the vertical angle intercepts. Okay, so that other one that I labeled as 1. And then you're going to divide it by 2. So again, to find the measure of angle 1, we would take arc AB, add on its vertical angles arc, which is arc DC, and divide it by 2. So that one corresponds to the one I highlighted yellow. Now, if I wanted to find the measure of angle 2, okay, you could take, again, the arc that angle 2 intercepts. In this case, that would be BC, right? And then its vertical angle intercepts arc AD. Okay, so to find measure of angle 2, you would take arc BC and add on arc AD. Then divide that by 2. Okay, so that one I highlighted pink. Okay, so that's the formula you use for intersections inside a circle. You have to look for the arcs intercepted by that angle and its vertical angle. So we're going to do a few examples below here. Okay, I'll keep that up there for a little bit. So for the first one, well, for all three of these, we want to find the value of x. So in 1a, x is right here. It's as that angle. So what I want to look for are the arcs that are intercepted by that angle. Well, x, if I follow that line, hits at point L and at point K. So we're looking at this intercepted arc here. Then we have to look at its vertical angle, so the angle across from it. That angle intercepts arc HJ. Okay, so those are your two arcs that you're going to take. So to find x, or our angle, we're adding that first arc, 116, plus the second intercepted arc, 47, and dividing it by 2. Okay, and you can just enter that into your calculator. It's 81.5 degrees. Okay, questions on the first one? All right, then if you look at the second one, 1b there, your x value right here intercepts this arc up here, right? But there's no measure for that arc. But I do have measures for this arc and for this arc. So what I can do is find this angle, okay, that I'm just going to label y. Okay, you can label it anything you want. Okay, I'm going to find that angle first. So I'm going to use those arcs intercepted by that angle, which are arcs NQ and MP. So to find y, we would take 75 plus 55 divided by 2. Okay, so that y value we get is 65 degrees. So that means this angle is 65 and this angle is 65. Now the reason I did that was because I know these secants are straight lines. What does a straight line have to be equal to? 180. So if I have one of the angles that make up that straight line, how do I find that second one? Subtract it from 180. Good. So to find x, we're going to take 180 minus 65. Hey, you were close.
No, I was not.
You said 120. 5 off. Okay, so x would be 115. So if you're not given the arcs intercepted by that angle x right away, but you can find the other angle, do that and then subtract it from 180 to get the angle you actually were looking for. Okay, does that make sense? No?
Are you going to do 1C?
Do what?
1C?
Yeah. All right, so last one on the front here is 1C. So this one, x is one of the arcs that you're looking for, okay? I'm given the angle, so I'm still going to use this formula here. Now where it says the measure of angle 1, that's your angle. So I'm going to plug in my angle for measure of angle 1. So I have 128. Okay, that's equal to the arcs intercepted added together. So my arcs intercepted by that angle would be WY and XZ. So I'm going to set that angle measure equal to my first arc intercepted, which is 154, plus my second arc intercepted, which is X, and that's still divided by 2. So if you notice, I just plugged each thing into that formula from above. My angle, my arc, my other arc, and then divided by 2. Okay, from here I'm just going to solve for X. So I'm going to multiply both sides by 2 so that they cancel on the right. So I have 256 equals 154 plus X. Subtract 154 from both sides of your equation. So X would be 102. Okay, so you're just using that formula. Okay, plug in the angle where it's needed, plug in the arc where it's needed. And again, if you get a problem like 1B, find that other angle first, and then find the angle that you actually had to look for in the first place. Okay, questions on those 3 problems? All right, so that was intersections inside a circle. The next one we're going to go through are intersections on a circle. Okay, so your intersections that are on a circle. That means that intersection point will be on the circle around that outside part. So this theorem says if a secant and a tangent, okay, so we talked about tangents, that's that line that hits your circle in exactly one spot. So if I have a tangent and a secant intersecting at a point of tangency, then the measure of each angle formed is 1/2 the measure of the intercepted arc. We have done problems like this already with inscribed angles. Okay, so it is saying that if you have these two lines intersecting at your point of tangency A, you can take the arc intercepted. So in this case, for angle 1, that would be AB. Take that arc and you just divide it by 2 to get your angle. Okay, so if I'm trying to find the measure of angle 1, I would take that arc intercepted, so it has an intersection point at the point of tangency, and the other point on your secant. So I'll take arc AB and divide it by 2. Okay? So if you have that intersection on a circle, you need to look for the intercepted arc with your point of tangency and the other point on your secant. Take that arc measure, divide it by 2. So we're going to go through some examples of that. So in 2A, we want to find the measure of arc JLK. So JLK is this arc right here. So that means I hit at that point of tangency J, and then all the way to my secant at point K. Well, in this case, I'm given the angle. So I'm going to plug in the angle for the angle in my formula. So I have 116 is equal to my arc, okay, so that is arc JLK, and that would be divided by 2 from my formula. Now to solve for that arc, I just have to times 2. So the measure of that arc JLK would be equal to 232 degrees. So again, I'm just plugging in those values into that formula to help me solve. All right, so questions on that one before I do the last one here? All right, so 2B, we want to find the measure of angle RQS. So that's this angle here formed by your tangent and your secant. Okay, we're also given that arc QTS, so from Q to T to S, is 238. Okay, well if that arc is 238, how do I find this arc right here? Yes, you're going to subtract it from 360. So both of these arcs together have to total 360. So take 360 minus 238. That's 122. So now that I have that arc that's intercepted by that angle, I can use my formula from above. Okay, so to find this angle, the measure of angle RQS, we're going to take our intercepted arc, which is 122, divide it by 2. To get 61 degrees. Okay, so today we just went over intersections inside the circle. Okay, so if you see two secants intersect inside the circle, so they have that intersection point that's inside the circle, use the formulas from the front of your note sheet. If you see your intersection point for your two lines that's on the circle, like these ones, okay, you have to use the back side of your note sheet to figure those out. Does that make sense? Do we have any questions?